Hello, I'm Dr. Gujo. I'm going to do a demo for you in a minute, but first I thought I'd tell you very briefly about myself. My background is as a spectroscopist, which means I study light interaction with matter, hence the rainbow-colored lab coat, where all the different colored dyes are absorbing different colors of light. Presently, my area of research actually is developing potential cures for the common cold. I do computational work to devise, find targets, and then I grow cells, human cells in the lab to test some of those target molecules. Today's demo isn't related to the cold virus or spectroscopy. It is simply a demonstration of a chemical reaction. It's going to be a reaction between sugar, which I've already put in this beaker, sucrose actually, it's just table sugar, and sulfuric acid. So, sucrose is a molecule made up of carbon, hydrogen, and oxygen atoms held together in a particular geometry. Sulfuric acid is a mixture of water and a molecule made of hydrogen, sulfur, and oxygen. This is very concentrated sulfuric acid, so it's very dangerous. It's highly reactive. As you always do in the lab, I'm going to wear goggles. I'm also wearing gloves today because of how reactive and dangerous the sulfuric acid can be. You don't want to get it on your skin. It can do damage. So, all I'm going to do is pour a little bit of the sulfuric acid onto the sugar, and you should watch what happens. Notice probably that it's already starting to turn sort of yellowish brown. And you can't tell, but I can tell it's getting quite hot. It may get hot enough to start spitting and smoking and stuff, so I have a beaker to put over it in case it does that. It depends exactly how fast the reaction goes, whether that happens. So, you're probably noticing the amount of black in there is increasing. The black is actually carbon atoms, pure carbon. The sulfuric acid is reacting with the sugar to remove the hydrogen and oxygen. So we're going to go from a molecule plus a mixture to a pure element, carbon. And this does take a little while for the reaction to finish, but you can probably see that it's continuing to get darker and darker. Swirl just to make sure that it's mixed. Watch this carefully. What you'll maybe noticing is that it's starting to grow out the top of the liquid. This does take a little while. So it looks like I'm going to be lucky and not have to cover this beaker for you. I'm going to actually push it forward a little bit so maybe you can see a little better. Stay away from the caption. So I can see, it may be hard in the video, it's starting to bubble pretty vigorously on this side. You see that something's growing out of it. That's the carbon. Okay, so now it's starting to smoke, so I'm going to at least protect myself from the vapors because they contain some of the sulfuric acid. If it gets really bad, I will cover the beaker. see the carbon growing up out of the sugar and sulfuric acid mixture as the water is boiled off. Okay, that looks like it's not going to produce so much vapor that it's going to be a problem for me. So, I ran this before already, just so you can see a little better. I took some of the carbon, rinsed it off so that I could handle it, and you can see it's black. It's what you'd expect. It's sort of like charcoal. It's porous because of the gas bubbles that forced it to come out of the solution. But it's a solid, and that's almost pure carbon. So again, we've got an element, a mixture,